Hi, my name is Pete Hahn, and thank you for watching this tutorial video. Be sure to visit www.hahn-tech.com for the full library of videos. I hope this video increases your knowledge and helps you become more efficient with this topic, whether for home or work. Please support this channel by sharing these videos with your friends and colleagues. This is part 2 of a two-part series. If you have not already watched part 1, you can access it by clicking the link in the upper left corner of this video. Let's start with a quick review of topics we covered in part 1. We learned the formula bar is where it all comes together. We worked with equations of various complexity and saw how to enforce order of operations. There were about a dozen examples of using the function wizard. We also covered the first 3 of the 5 fundamental concepts of functions. We found that arguments are the inputs, and these inputs need to be of the correct data types. Once these 2 fundamentals are met, the function outputs a return value. We also saw a difference between equations and functions. We first looked at those qualities each has in common, and then we learned those qualities which make them distinct. Those differences seem subtle, but have significant impact on your understanding of how to apply them effectively. As we look at this slide, you should be reminded that functions behave very much like little factories. Raw ingredients go in and finished products come out, while their inner workings are mostly hidden from view. Here is a preview of topics we'll cover during part 2 of this series. We'll discover the last 2 of the 5 fundamentals of functions. They will remain hidden for now, don't worry, I will make sure you don't miss them. We'll be reviewing 3 more groups of functions, 2 of which have unique qualities which will help introduce you to the last 2 fundamentals. To finish things up, we'll play with a group of functions designed to work with text values. Ready to get started? The next group of functions are those which have a defined number of non-optional arguments. I have listed arguments 1 through 3 in columns D, E, and F. I will use those values for the arguments of each function through the use of cell references. Each of these are from the date and time category. Notice here, as I click on the cell for argument 1, the value of the cell is displayed by the wizard. If instead we saw an error, it would mean that we provided an invalid data type. Notice, however, at this stage, the formula result is null. Not until we provide the final required argument do we see the formula return value. I will type an equal sign in D5, then click cell C4 to create a reference to that cell's value. After pressing enter, cell D5 mirrors whatever value is in C4. With this next function, you will see that you can subtract 2 dates and find the number of days between them. This function takes only 2 arguments, which I will provide using cell references as before. Watch closely as I insert the cell reference for argument 1. See that the formula result is empty. Once I provide the values of correct data types for each of the required arguments, only then will the function return its value. I'll fast forward this one until we get to the last argument. Looks like you're getting the hang of this. Notice as the third and final required argument is provided, the function finally provides a return value. Next up, we'll discover a group of functions that have optional arguments. Once again, I have set up my argument values ahead of time. I will use cell references to feed these values to each function's arguments. We're going to see a bunch of error codes here. This is intentional, as I want to use them to fully explain this topic. As we feed values to the function wizard, there's a very subtle clue that one of these 2 arguments is optional. Did you spot it before I highlighted it? A return value after providing only the first argument, and once I entered the cell reference for the second argument, the return value went blank. As we close the wizard, we see the return value is an error code. Okay, well, let's try the next function. See if we can work this out. Keep your eyes on the formula result this time. Watch as the first argument reference is entered. We immediately get a return value, which vanishes as soon as the second argument reference is entered. The cell is empty, but is interpreted as a 0. We see from the description only a 1 or a 2 is allowed for this argument. Okay, we should have enough information to fix this now. But first, I'll copy and paste these functions into the next 2 rows. Then, I will enter a valid value for argument 2 in rows 4 and 5. Sure enough, this clears up the error, and we get a valid return value. Now watch as I bring up the function wizard for one of the ones producing an error code. Let's erase the cell reference for the second argument and see what happens. We get a return value via the formula result. and when we click OK, we see a valid return value in the cell. So from this we know that argument 2 is optional. However, any value provided for this optional argument must still be of the correct data type and within range specified in the argument's description. I'll pause for a moment and let that sink in. Okay, hope your batteries are fully charged, because now we get into some freestyle function entry. That's right, we're leaving the function wizard behind as we dive headfirst into fundamental concept number 4, formula bar entry. Clicking on the formula bar, I begin with an equal sign and type out the name of a function. I then enter D4 for the cell reference for the first argument. Next is a comma, and watch as Excel pops up an interactive help menu. See anything different between these two arguments? Return type is in brackets while serial number is not. The brackets specify that arguments are optional. The pop-up help menu provides a list of acceptable values along with a brief description of each. Clicking on one of these causes that value to be added to the formula bar. We enter a closing parentheses and press enter to complete our function. Now watch as I modify the function in the formula bar, replacing the 1 with a cell reference of E4. I press enter to complete the function and the function is updated. Let's do another one, but this time I will type directly into the cell. Notice the very same pop-up help menu is provided by Excel. Watch closely as I type out the function statement. The pop-up help menu gives a suggested list of functions, and once I enter the first parentheses, see how the first argument changes to bold type. Once I enter the comma, the bold type moves to the second argument. I type the cell references E5 and add a closing parentheses, pressing enter to complete the function statement. That was probably a lot to take in. It gets easier from here. The next group of functions takes us into the great unknown. See, I don't feel comfortable using the word infinite. I mean, how do you confirm something is infinite when you have no way to measure it? When dealing with non-philosophical topics, I prefer to use the term undefined. It's not that there are no limits, just that sometimes the limits are not readily defined. Watch what happens to the list of arguments as I enter cell references. Each added cell reference causes another argument to be added to the list. Watch the formula result as I do the next one. From the very first cell reference, this function outputs a return value. Even though this function takes an undefined number of arguments, we can see that only one is required. I'll fast forward through these next few because I can hardly wait to discuss the next topic. I'm going to duplicate each of these function statements, but with an added twist. Instead of listing each cell reference as a separate argument, I will click and drag to select several cells in one step. Here it comes. Ready? We can see the resulting argument references cells using the first and last cell separated by a colon, D11, G11. This creates what is known as a cell range reference, which brings us to our fifth and final fundamental concept, ranges. Cell ranges are very handy, and I use them quite often in my projects. This is not to be confused with what is called named range, which is a topic for more advanced tutorials. Notice, as each function statement is completed, the return value is exactly the same as if each individual cell reference had been added as an individual argument. I'll fast forward here. You can pause to examine the details. I'm going to demonstrate an important point using these next two function statements. They are built exactly as the ones above, using cell ranges. The only difference is I have modified the values in some of the cells we are referencing as arguments. One of the 4 cells is empty while another contains text rather than a number. What do you suppose is going to happen? An error? After all, we have invalid data types in our arguments. What's this? No error code? Let's see that again. Just as before, we'll use a range of cells as the argument. We can clearly see there are invalid data types in 2 of these cells. Why are these not producing error codes? Whether this is a bug or intentional behavior, we must be aware this potential exists. It seems as though further steps are required to ensure against bad data, which is a topic for more advanced tutorials. Last item I'll point out here is a matter of curiosity. Just how many cells can you put in a range before Excel complains? In this example, I've created a formula with a range consisting of 1,048,576 cells, the current maximum rows you can have in a single worksheet. Coming up next will be the final group of functions, ones which work with text. We'll kick off this session with a nice 4-syllable word. Concatenate is a function which takes an undefined number of arguments and appends each to the end in series. The data type of its return value depends what it contains. For instance, when the return value contains only numbers, the return value is treated as a number by other functions. When the return value is formatted as a date, other functions can use its value as a date. When neither of these conditions apply, its return value will be treated as text by other functions. Given the similarities to some functions we just covered, it would be easy to assume you could use a range of cells for its arguments. But that is not correct. Cell ranges in any argument of this function produce an error code. Next, I will demonstrate a similar result can be accomplished by constructing an equation using the ampersand between each element. You can use cell references as shown here. There appears to be an undefined quantity of these you can string together. When you press enter, the equation is evaluated and the return value is essentially identical to the concatenate function. You can also include values directly in the equation, but you need to be careful or you will generate an error code. If you include values in the equation in place of cell references, just be sure to place the value in quotes. This tells Excel the value you placed in your equation should be treated as a text value. There are a large variety of text-based functions to choose from. I use them often in my spreadsheets when I need to modify or adjust text values or combine text with numerical values. The exact function compares its two arguments and returns true or false depending on whether the two arguments are exactly the same. Any function which returns a value of true or false is considered a Boolean function. These functions are very useful when building complex formulas which you create to manage error conditions in your workflow. The left function takes two arguments. One is the subject text value. The second is a numeric value which determines how many characters from the left edge of the subject text are in its return value. Next up is the len function. It merely counts the number of characters in the subject text, which is its only argument. The last one I'll show in this group is a transform function. It transforms its subject text to all uppercase characters. This concludes the two-part series titled 5 Fundamentals of Spreadsheet Formulas. Let's scroll through the topics covered in this series. Formula bar, equations, order of operations, the function wizard, the 5 fundamentals, which are arguments, data types, return values, formula bar entry, and ranges. We studied 5 distinct groups of functions and ended with a final group of functions that handle text elements. Be sure to remember that functions are just like little factories. Raw ingredients go in and finished products come out, but we don't get to see much of what goes on inside. I hope this series was enjoyable to view as it was to produce. I truly hope you learned many valuable skills during our time together. Be sure to visit www.Hahn-Tech.com for the full library of videos. Please support this channel by sharing these videos with your friends and colleagues. Be sure to subscribe to this channel to receive updates when new videos are published. Thanks and take care.